Hi students, okay, today we are learning the topic is vector integration and the first lecture on vector integration. So in the previous lecture we completed vector differentiation, okay na? So in the vector integration we learning the topic is line integral, surface integral and volume integral. So already finding the integration in the lower classes and previous units. Okay, line integral means single variable integration. Okay, surface integral means which is converted to the double integral. So volume integral means that is the triple integrations. Okay, this is the first part, line integral, surface integral and volume integral. So first of all we will discussing the definition of all line, surface and volume integrals. Okay now, the first one is line integral. So see, the definition is any integral which is to be evaluated along a curve or any line is called line integral. So that is integration finding along the curve, that is called simple definition line integral. So how to define in the vectors form line integral? So see, the mathematically given. So your assumption, let f bar be a vector function defined at every point on a curve C, and r bar is the position vector of a point P on the curve. Then the line integral of f bar over a curve is defined as, that is integration over C f bar dot dr bar. So f bar is any vector function which is defined at every point on the curve and r bar is a position vector. Then integration over C of vector field f bar is denoted by integration over C f bar dot dr bar. So f bar is a vector, dr bar is a vector. Dr bar is the differentiation of position vector r bar. Okay, now this is called line integral. So how to define the this value? See that. So that is, let f bar is equal to f1i plus f2j plus f3k, where f1, f2, f3 are real valued functions, that is the scalars in xyz, and position vector at any point P on the curve C AB is r bar. R bar is equal position vector, which is assumption xi plus yj plus zk. Okay, so that is equal to differentiation of this vector dr bar is equal to dxi plus dyj plus dzk. So therefore line integral along the curve C, C's curve is AB, that is equal integration from A to B f bar dot dr bar is equal to, which is can be write f bar dot dr bar means dot product of the two vectors f bar and d bar, that is f1 dx plus f2 dy plus f3 dz. So this is the defined by line integral along curve C or AB. So this is the definition of line integral. So next definition, continuation. So if that is work done by a person, and a line integral is represents by work done. This is geometrically representation, work done by force, and that means any particle is moving along the curve with the force f bar. Then the line integral is represents work done by force of the given a particle from the point A to B is defined as, that is work done is equal to integration from A to B f bar dot dr bar, that is a line integral of f bar is called work done by force of a particle along the curve from A to B. So that is a line integral is represents as work done. Okay. So see, the next one is circulation. So circulation is also called line integral, but given curve is closed curve, that is the integration of the vector field along the closed curve is called circulation. That is, a line integration is represent circulation when given curve is closed curve. That is equal to, let C be is a simple closed curve, then the line integral of f bar along C is called circulation of f bar along C. It is denoted by integration over C f bar dot dr bar. This is also line integral is represents as circulation when the given curve is closed curve. So the symbol is a given C is a closed curve and there is a meaning. Okay, now this is a circulation, and that means line integral, work done, circulation, all are same. Okay, this is the line integral, the first part. So there is a circulation. So see the next note here. If the circulation of f bar round every closed curve is 0, that is integration of f bar dot dr bar, that is a line integral, is equal to 0, then f bar is said to be irrotational vector when the line integral of the given vector field is 0 along the a closed curve. That is called, the vector field is called the irrotational vector. Next one, if f bar is irrotational vector or conservative, then the line integral of f bar is independent of the path. Thus, a line integral depends only on the start and end values. And when the given vector field f bar is the irrotational vector or conservative, what is the meaning of irrotational vector? That f bar is can be write a gradient of a scalar field, and f bar is equal to del pi. Then the line integral is must be independent of the path. That means, what is the meaning of independent of the path? The line integral value is depend on the only start and end values. For example, the from the curve from A to B and A. So at the point P and at the point P, the value is depend on the A point and B point. That is called independent of the path when the vector field must be conservative or irrotational vector. This is the second two. Next, third one, the line integration over C f bar dot dr bar is independent of the path C if del cross f bar is equal to 0 bar. That means we have to show that the given line integral is independent of the path. Then how to show that? What is just showing that vector field conservative. That is enough to show that del cross f bar is equal to 0 bar. When del cross f bar is equal to 0, the line integral of f bar is independent of the path. This is one of the note of line integral. Okay, is understood clearly? Yeah. Second one, surface integral. So see the definition of surface integral. So any integral which is to be evaluated over a surface is called a surface integral, which is the generalization of a double integral over a plane region R. So surface integral, that is integration evaluating over the given surface, that is called surface integral. So but the surface integral cannot be finding directly, which is the generalization to the double integral, that is converted to the surface lies in a region, that is a plane, that is R. So therefore the double integration of the given over the region R is called the surface integral of the given over the surface. Okay, now this is the surface integral. See that definition again mathematically. So let f bar is equal to f1i plus f2j plus f3k is the vector point function, where f1, f2, f3 are scalars, and s be the given surface. Then the surface integral of a vector function f bar over the surface s is denoted by this one, integration over s f bar dot n cap ds. So this is a double integration over s f bar dot n cap ds, where n cap is unit normal vector to the surface. F bar is a given vector which is defined on every point on the surface S, and n cap is drawn a unit normal vector to the surface S. So this is called the surface integral. So if the equation of the surface S is phi of x comma y comma z is equal to 0, this is a surface equation given, then the how to finding the n cap unit normal vector to the surface is del pi by mod del pi. This is a formula for finding unit normal vector to the given surface. So this is the surface integral. So next definition, flux. So flux is the representation by the surface integral. This is a geometrically representation of surface integral. See, the definition is, if f bar represents velocity of the fluid at any point P on a closed surface S, then the surface integration over S f bar dot n cap ds represents the flux of f bar over S. See that. So here f bar is represents velocity, and velocity of the any fluid. That fluid is flowing through the surface. Okay, now then the surface integral of f bar over S is called flux. That is, the surface integral is represents of the given vector field is flux. What is the meaning of flux? That is volume of the fluid flowing out from the surface for unit time. In the unit time law, how much fluid is flowing out from the surface, then the volume of that fluid is called flux. Okay, now is clear? Volume of the fluid flowing out from the surface is for unit time, that is called flux. Flux means surface integral. So note, if surface integral is 0, and that is flux is 0 over S, then the vector f bar is called a solenoidal vector function, and a flux 0 only. The surface integral is 0, then the vector field is called solenoidal vector function. So this is the surface integral representation by flux. Next one. So evaluation of surface integral. Then how to finding the surface integral? So this is the surface integral is generalization to the double integral in the region. See the given formulas here to finding the surface integral. So a surface integral is evaluated by expressing it has a double integral over the region R. The region R is the orthogonal projection of S on one of the coordinate planes, that is xy plane or yz plane or zx plane, and now projected. Now assumption the orthogonal projection of the given surface on the opposite plane, any plane, xy plane or yz plane or zx plane, that is given, that depend on the given surface, and surface directly in the plane, directly finding the surface integral by using the double integral. In case the surface is not in the plane, for example the surface given on x-axis or y-axis and z-axis, then now we have to finding the projected of the given surface, that is the assumption the projection of the given surface, then opposite sides, then converted to the region, that is a double integration. So then how to finding the double integration using this formulas here. So let R be the orthogonal projection of the surfaces on xy plane. Then in case the assumption the projection on the xy plane of the given surface, then how to finding the surface integral. So that is equal formula is given. This is a surface integral over S is equal to, which is converted to the integration over R. R is a projection in the plane, xy plane. So f bar dot n cap is equal to dx dy by mod n cap dot k cap. And ds is equal to here double integration and dx dy xy plane by mod n cap dot k cap. ఇక్కడ n cap k cap is the direction vector to the surface opposite here, xy plane opposite z axis, that is a z cap. K cap is the direction unit vector along the z axis, that is a choosing the formula. So this is one of the formula to finding the surface integral when the projection in xy plane. Okay na. Similarly second one, in case let R be the orthogonal projection of the surfaces on yz plane, then so that is surface integral is equal to integration over R f bar dot n cap dy dz by mod n cap dot I. This is the second formula when the projection in yz plane. So third one, let R be the orthogonal projection of the surface S on zx plane, then surface integral over S is equal to integration over R f bar dot n cap into dz dx by mod n cap dot j cap. This is the surface integral when the projection of in zx plane, using any formula to finding the surface integral which is depend on the given surface in which place, that is a important. Okay. So next one. So third one is volume integral. So volume integral means triple integrations, okay na, in the vector form. So let f bar is equal to f1i plus f2j plus f3k be vector function and volume v enclosed by a closed surface. Then volume integral of f bar in the finite region v is denoted by integration over v f bar dv. And the dv is a volume integration dx dy dz. So that is a triple integration over v f bar dx dy dz. This is called volume integral over v of given vector function f bar. Okay, this is a simple definition and volume integral. Yeah, thanks for watching this video. For more videos, please do subscribe my channel, like and share it. Thank you.